Okay, for homework 418, I'd like you to copy this work and the words to show me that you listened. Maybe go back and do the homework 414 that was worth 50 points. Some of you need to do that. So this is homework 418. Shouldn't be 2 up there. I'm not sure why I put that. All right, what I want you to do is find the 4th point for this square. Pretty sure I had you draw these first 2 coordinates, or 3. I want you to find the 4th. I want you to see that I'm going to be coming at this using the same slope as this line segment right there. I need to be able to reproduce that pattern. If I look between B and C, that is going right 1, down 4. That is a slope of -4/1. Right 1, down 4. That means for my new D point from A, I'm going to be reducing that pattern. Right 1, down 4. If I do that, that will make sure that that line has a point that's parallel and the same distance between B and C. So here we go. From A, right 1, down 4. That is where my next point, my 4th point of this square, is going to be. First word is green. Green. Now what I need you to do is prove this is a square by proving that a line going through these 2 points at each corner give me a 90-degree perpendicular angle situation. So I'm going to be doing 4 separate slopes to compare to show that this square has 4 right angles. So here we go, cranking out the slope. Slope between A and B. First thing I'd like you to do is write down all of these coordinates and double check that these are correct. There's my A, my B is 1, 3, my C is the point 2, -1, and of course my new point D that I just got by reproducing that is -2, -2. Don't mess up on the coordinates. Know that these are the X numbers. The other part of the coordinate are the Y numbers. For distance and slope, you're just finding the difference. You're always subtracting. To find the slope between A and B, I am subtracting the Y numbers from this coordinate pair up on top over the X coordinate numbers being subtracted on the bottom. So if I do that correctly, A and B, which again I could clearly see is a slope of over 4 up 1, over 4 up 1, 1/4. I should be getting that from getting 2 minus 3 over -3 minus 1. That gives me -1 over -4, which simplifies into 1/4. Matches that slope that my eyeball gave me. Now my eyeball says these should be a -4/1, or sometimes if you do the work, -1 on the bottom. Those are the same. Remember, let your eyeball kind of give you an idea of what you're going to be looking for on these. So if I do A and D, I should get the opposite reciprocal of 1/4, the flip-flop and the opposite, negative. So A and D, I'm going to do 2 all the way down there minus another -2. And then for A and D, I'm going to do -3 minus -2. That gives me 2 plus 2 over -3 plus 2. That gives me that 4 over -1 look. But remember, the way I like it is written like this, where you're going right 1, down 4. So again, looking at that supports my math. Both those show a right angle. If I have a 1/4 slope going this way and then a -4/1 going this way, that proves that's a right angle in there. All right, I need to do the other slopes. I'm going to do B and C, knowing that I'm going to get that same -4/1 at the end. So B and C, I'm going to do 3 minus a 1 that's already negative, that's a double negative, over 1 minus 2, that gives me 3 plus 1 over negative 1, that gives me 4 over negative 1. Remember, that's negative 4 over 1. That is the opposite reciprocal, the flip-flop reciprocal of 1/4. Opposite and flip-flop. And then my last slope, of course, my last slope is going to be DC. I'm going to do CD, really. Doesn't really matter. I'm going to do CD. So I'm going to do negative 1 minus 2 for CD. Negative 1 minus 2. I'm doing this pair right here, left to right. And then I'm doing this pair on the bottom. So that gives me 1 minus 2 on top. On the bottom, 2 minus 2. Ends up being negative 1 plus 2 over 2 plus 2. That is 1 over 4, 1/4. So that work supports my statement that this has 4 right angles. I've proven that a line going through those line segments all are negative opposite reciprocals of each other. My next step is to prove that this square has equal lengths. So let's try to do that. Let's shrink this down a little bit. Second word is wave. Wave. All right, so those are my 4 slopes. All of them are either parallel, you could see. These have the same parallel 1/4 slope. These are parallel also, which makes this technically a parallelogram, 2 pairs of parallel sides. Now for it to be not just a parallelogram, but a square parallelogram, I got to prove that those 4 lengths are equal using the distance formula. So here I go. First one, if I do A and B, distance now, I'm doing the square root of negative 3 minus 2. Oh, sorry. Let's do A and B. Make sure I'm using the right coordinates. So the length of A and B is the square root of negative 3 minus 1 squared plus 2 minus 3 squared gives me the square root of negative 4 squared plus negative 1 squared gives me the square root of 16 plus 1, which is the square root of 17, knowing that all of my lengths are going to be the square root of 17 if I do my work correctly, because this is technically me proving that it's a square. 4 right angles, 4 equal lengths. All right, let's do the others. Shrink this down a little bit if I could. All right, let's do AD. Again, support your math. AD is going to be, let's go the y's first, 2 minus 2. Let's go negative 3 minus 2. That gives me 2 plus 2 squared plus negative 3 plus 2 squared, square root of 4 squared plus negative 1 squared gives me square root of 16 plus 1, square root of 17. I got to do 2 more. All should be getting you root 17. All right, let's do DC. How about that? Or CD. How about that? CD. Keep it alphabetical. So CD, let's go negative 1. Let's do the y's first. Negative 1 minus 2 plus 2 minus 2. positive 1 squared, positive 4 squared gives me 1 plus 16, which is root 17. Technically, to get full credit, I'm going to have to do one more length, getting another root 17. I'm going to do B and C. Let's put that over here. So I did AB, AD, CD. Now let's do BC. So BC is the square root of, let's go the y's first, 3 minus 1, 1 minus 2, gives me square root of 3 plus 1 squared, gives me 16 plus 1, which is root 17. And now the last bit is using those lengths. Now find the length of this diagonal, knowing that that part of the triangle that I'm dealing with right there is a right triangle. I have two lengths right here of root 17, root 17. I prove that's a right angle. To find that diagonal in the middle, which is technically C, I'm going to use now the Pythagorean theorem. What I've used so far here was the distance formula, the slope formula. Now I'm going to use the Pythagorean theorem, knowing that Pythagorean theorem is a little bit different. It does not have you subtract the x and y numbers. That's distance, and slope has you subtract the x and y numbers. For Pythagorean theorem, it's just a squared equals c squared equals a squared plus b squared. So I'm going to plug in into this c squared equals the square root of 17 square root of another 17. That gives me c squared equals 17 plus 17, because remember, if you times two of those root 17s, what you get is this kind of madness right here. Root 17 times root 17. And if you times those 17s together, it gives you square root of 289. And if you square root of 289, pops back to the whole number 7. So square rooting and squaring, inverse operation. It's not magic why those go away, but it does. And then this gives me c squared equals 34. Square root both sides. And that gives me c equals a square root of 34, using the Pythagorean theorem the correct way. All right, third word is turtle. Turtle. Good luck. Distance formula, Pythagorean theorem formula, and then of course distance formula.